Welcome to Monkey Physics IIT JEE NEET Foundations.
So let's take some other examples connected to motion under gravity. So here it is, an object is dropped from some height h. Now the question description how it is given is it has fallen for t equivalent to 2 seconds, and after 2 seconds gravity ceases. So gravity ceases. What does it mean? The gravity disappears. That means the gravity is all of a sudden disappears. Of course, it is hypothetical case. Where can we get this situation? Means no way we can get this situation. But I mean, logically, conceptual wise, are you aware of the applications? That is what for checking. Now, the object is dropped from some height. After 2 seconds, gravity ceases, and again from this instance the object is taking to reach the ground 2 more seconds. So this is a gravity 0 region, and this is acceleration due to gravity is equal to g. So in this, now what is the question is, what is the height from which it is dropped? So the what is the height from which it is dropped? Now it is clear. Once it is dropped, the gravity ceases after 2 seconds, and again it takes 2 more seconds to reach the ground. Then what is the height from which it is dropped? Is it clear? I hope it's clear to you all, right? Now how can we do? Now split it into 2 categories. This is category number 1, constant acceleration, and this is category number 2 with the 0 acceleration. This 0 acceleration case is nothing but we can take it as a constant velocity case. Constant velocity. Now let me take. This is the total height h. Now it is drop. So u is equal to 0 in 2 seconds. So how much depth it falls? Use s is equal to half g t square. Because initial velocity 0, no? Otherwise we should use s is equal to ut plus half a t square. Now how much depth it falls? H is equal to 10 by 2 into 2 square. So it is nothing but 20 meters it has fallen in 2 seconds. Now after falling this much depth, what is the velocity? Velocity is equal to 20 meters per second, isn't it? And we did it already number of times. Now if you want this, how do we get v is equal to u plus at? It is nothing but u plus gt, and it is nothing but gt. So g is 10, t is equal to 2 seconds. Okay, so it is nothing but 10 into 2 is nothing but 20 meters per second. So t equal to 2 seconds here, the velocity is 20 meters per second, and no more acceleration. This 20 meters per second it continues. Okay, and how much is this depth? h1 is equal to 20 meters. Now h2, how to find h2? I told you now already, it is a constant velocity case. So no more change in the velocity because gravity ceases, no acceleration. Therefore, velocity 20 meters per second. So in 1 second, how much depth it falls? 20. Now they are asking us, it spent 2 seconds in this region, right? So 2 seconds, how much depth it falls? 40 meters. Now what is the total height of the building? 20 plus 40. So total height of the building is nothing but, total height is nothing but 20 plus 40 is 60 meters. Okay, and take it as a note. So this is the height of the building. The object is dropped, initial velocity is 0. General case, if t equal to 4 seconds, in general, not this condition, without this condition. This is the condition intentionally given, but if this is not the condition, general case, in 4 seconds, how much depth it falls? H is equal to, we should use this directly. What is that? Half g t square. So 10 by 2 into 4 seconds, 4 square. So 5 into 16 is nothing but 80 meters. So if gravity ceases case is not given, then in 4 seconds, how much depth it falls? 80 meters. And now because of gravity ceases here, it is not accelerating, it is continuing with the constant velocity, and that is the reason we have taken this. And what is the formula we use to get this? Did you get that? Now, in common I have taken 2 seconds, it's moving with constant speed. So 1 second it moved 20 meters they have given, and in 2 seconds 40 meters it moves. That's what we have taken. But generally, displacement is velocity into time. Displacement is velocity into time. And again, how come it is we know s is equal to ut plus half at square. If acceleration is 0, this formula you should use. Otherwise, s is equivalent to half at square. If initial velocity is equivalent to 0, we should use this. That's the reason. Yeah. Thank you.